Welcome back to section 6.2, finding inverse algebraically. In this section, we're going to focus on finding inverse when we have x squared. So we're going to be using the same rules, the same 4 rules on finding inverse algebraically, but this part is mainly on how to work when you have an x squared. So let's take a look at example 1. Example 1, we have g of x equal x squared plus 36. So, found the same set of 4 rules shown previously. Step 1 is to convert g of x into y. So, when we have that, it's going to look like this. Y equals x squared plus 36. Alright, step 2 is to switch x and y, meaning that everything stays the same. So the equal sign stays where it is, the plus stays where it is, the 36 stays where it is, including the square. So we see the square on the x. The square, the 2, stays where it is. Only the two things that's going to switch places is the x and y. So when they switch places, this is what's going to look like. X equals y squared plus 36. So, like I said before, everything that's not the x and y stays where they are. The equal sign, the square, the plus, and the 36. The only thing that switch places is simply the x and y. So again, make sure you take note of that, because what I have seen in the past year is that I've seen people switch with the square when I only said that the x and the y only switch places. Everything else that is not the x and not the y stays where they are. So again, when I swap the x and y, the equal stays where it is, the square stays where it is, the plus stays where it is, and the 36 stays where it is. So simple as that. So we're going to start using inverse operation, meaning opposite operation, to solve for y, meaning get y by itself. So the first thing that we want to do to get y by itself is mainly to get y squared by itself. So that means we have to get rid of the plus 36. So to cancel out plus 36, I'm going to subtract 36 on the right side, therefore subtract 36 on the left side. So it's going to look like this. So minus 36 on the right side, therefore minus 36 on the left side of the equal sign. So when I subtract, so on the left side, x minus 36 are two different terms. So it's going to look like x minus 36 on the left side of the equal sign. And then when you cancel out the 36 on the right side, you're just left with the y squared. So at the moment, I have x minus 36 equal y squared. Now we one step closer to getting y by itself. So here we have y squared. So in order to get rid of the square, I had to do the opposite. So the opposite of square is called square root, which we had worked before. So as you can see on the right side of the equal sign, I put the square root on y squared because I want to get rid of the square. So if I do the square root on the right side, I have to do the square root on the left side of the whole thing. Since I had x minus 36 on the left side, I put the square root over x minus 36, as you can see here. Now, another thing is that when you do the square root, we have to include plus and minus. Now, we covered last semester in the previous chapter that when we do a square root of a number, we have the possibility of two answers. So, for example, if I ask you to do the square root of 25, the two possible answers is 5 and negative 5. The reason is, if you square 5, you get 25. And if you square negative 5, you will get the same answer, which is 25. So hence, when you do the square root, there's two possible answers you're going to get, which is the plus and minus. But again, since I had x minus 36 on the left side, two parts, if I'm going to square root the left side, I'm going to have to square root the whole left side, as you can see here. And again, the reason I'm doing the square root is so that I can get rid of the square. So when we do square root of y squared, and I repeat, the square root of y squared, then we're just going to end up with y on the right side. So now I have y by itself. So I am almost done. What I'm going to do is I'm going to switch the sides so that the y is on the left side. So when you flip the whole side, this is what it's going to look like. Y equal plus and minus the square root of x minus 36. So since the y is by itself, step 4 is to convert y into the inverse function. So since we had g of x, the inverse will be g to the negative 1 of x, right here. So g to the negative 1 of x equal plus and minus the square root of x minus 36. So this is going to be our answer. So again, when you do the square root, make sure to include the plus and minus. Now, I want to emphasize again, since I had two parts on the left side, the x and the minus 36, so if I'm going to do the square root of one side, so I'm going to have to do the square root of the left side, I have to put the square root over the x minus 36 as 1. Now, I have mentioned before that the minus 36 is inside the square root. As you can see, it's right underneath the square root line right here, or sometimes I would call it the house. Be aware that sometimes you, or should I say, know the difference when a number is inside the square root versus outside the square root. Moving on to example 2, we have h of x equals x squared divided by 15. So step 1 is to convert h of x into y. So it's going to look like this. So we have y equals x squared over 15, or I could say it as x squared divided by 15. Now step 2 is switching x and y in their places. So just like example 1, everything that is not the x and y stays where it is. The equal sign, the square, especially the square, and the over 15 or divide by 15. So when I switch x and y, this is what we have. X equal y squared divided by 15. So after the swap between x and y, we're going to use opposite operation to get y by itself. So since we're dealing with a fraction here, so what we do is that for fraction is we're going to multiply both sides by the denominator of the fraction. So in this example, since the denominator is 15, we're going to multiply both sides of the equal sign by 15, which is going to look like this. So on the left side, when I multiply, I'm going to have 15x. Now on the right side, when I'm multiplying by 15, I'm going to do this step by step to see why the 15 becomes 1. And you'll hear me say that it will divide into 1 versus, as you probably heard from others, cancel out, which again, I don't agree with that term. Here, I'm going to say it will divide into 1. So when you have a whole number multiplying to a fraction, which I would recommend to write this down because this will come up again. So when you have a whole number multiplying to a fraction, we're going to multiply the whole number to the numerator. So I'm multiplying the 15 to y squared. So I'm going to have 15y squared at the top. And my bottom, my denominator stays the same. So it's going to look like this. So 15y squared in the numerator because the 15 whole number will multiply to the top. My denominator stays the same. And again, when I multiply by 15 on the left side, I get 15x. Now, let's take a closer look at the right side of the equal sign. I have 15y squared over 15. So let's focus mainly on the number. Again, you can only do this if the top part is just simply multiplying. If it's adding and subtracting, that's a different story. But since it's multiplying between the 15 and the y squared, we can focus on the number. So we have 15 on the top, we have 15 on the bottom. We can simplify that fraction 15 divided by 15 will become 1. So 15y squared divided by 15 will be 1y squared. It's going to look like this. So we have 15x equals 1y squared. Now, I don't have to worry about dividing by 1. Again, the 1 can become invisible and you're just left with the y squared. So again, I don't have to worry about dividing by 1. If it's 1 or positive 1, then so far I'm good. So basically, if it's 1y squared, it's the same thing as y squared. So since I got y squared by itself, in order to get rid of the square, I have to do the opposite, which is square root. So I'm going to do the square root of both sides. So when I do that, it's going to look like this. So on the left side of the equal sign, it will be plus and minus square root of 15x. And on the right side is the square root of y squared. So when I do the square root of y squared, on the right side, it will be simply y. And on the left side, there's nothing I can do to simplify, so it stays the same, plus and minus square root of 15x. So since I got the y by itself, invisible 1 in front, and invisible 1 as the exponent, so you don't see that square anymore, I'm going to flip the whole thing, so that way the y is on the left side. So when I flip, it's going to be y equal plus and minus square root of 15x. Now, since y is by itself, I'm going to move on to step 4, which is to rewrite it as the inverse function. Since we start off with h of x, then my inverse will be h negative 1 of x, like so. So again, h negative 1 of x equal plus and minus square root of 15x. So this will be our final answer. I'm going to box that in red. So again, make sure to include plus and minus on the square root. Now moving on to the last example, we have m of x equal 81x squared, or also known as 81 times x squared. Now this part, I would recommend to pay close attention and, if possible, annotate or write additional notes so that way you can remember the steps and what you need to remember to do when you have this type of problem. So just like all the other example, you're going to rewrite m of x into y, and it's going to look like this. Y equals 81x squared. Now step 2 is swap x and y, so everything stays where they are, the equal sign, the 81, and the square. So when I switch x and y, we have x equal 81y squared. Now we're going to move on to step 3 using opposite operation, so that way we can get the y by itself. So here, the first thing we're going to do is we're going to divide both sides by the number that is in front of y squared. So in this example, we're going to divide the left and the right side by 81. So this is what it's going to look like, dividing both sides by 81. So now you see that on the right side of the equal sign, it looks very similar to the last example. Since 81 is multiplying to the y squared, you can focus on the number. So 81 divided by 81, that will be 1. So on the right side of the equal sign, when we have 81y squared divided by 81, we're going to end up with 1y squared. There we go. So that's just very similar to the last example. And again, you did not hear me say cancel out. You only heard me saying the correct term, divide into 1. If I were to say cancel out, that means it becomes 0 or disappear. Again, over here, it did not become 0. It did not disappear. It just simply 81 divided by 81 simply become 1. Now on the left side, we still have the same thing, x over 81, or x divided by 81. Now, Like I said in the last example, if you have a positive 1 y squared, essentially it's the same thing as y squared. Now, what we're going to do is try to get rid of the square. So the opposite of square is square root. So I'm going to square root both sides. So when I do that, take a closer look at the left side of the equal sign. So when I do the square root, notice how I did the square root of the whole fraction, the top and the bottom. And again, this is just a review of what we did for Chapter 5, Laws of Exponents. Now, when we do a square root of a whole fraction, we have to pay very, very close attention, especially on the denominator. Now, just to go over the right side, it's just like all the other example that we did. So the square root of y squared will simply be y. Now here, when you do a square root, make sure you include plus and minus. Now for fraction, what you can do is split it into two square roots. You're going to have a square root in the numerator and a square root on the denominator. But like I said before, the square root of y squared is simply y. Now let's focus on the fraction. Like I said before, we're going to split it into two square roots. So when you do that, it's going to look like this. Plus and minus square root of x over square root of 81. Now the reason I did that is because if you look closely to the denominator, 81 is a perfect square number. So since 81 is a perfect square number, you can do the square root of it. So the square root of 81 is 9. So when I do that, it's going to look like this. So what I have is plus and minus square root of x over 9. So again, the square root of 81 is 9. Again, the reason I'm repeating that is because I did not say square root of 9. I just simply said 9. What I've seen in the past is when people say the square root of 81, they say 9, and I tell them to write exactly what they said. Half the time is where they accidentally wrote the square root on a 9. So again, just make sure to write down what you know, what you said. For example, the square root of 64 is 8, meaning that you just write down the 8 and not include the square root. Since the y is by itself, I'm going to flip the whole thing so that way the y is on the left side. And then when I do that, make sure to convert, for step 4, convert into the inverse function, m to the negative 1 of x. So when I do that, we have m to negative 1 of x equal plus and minus the square root of x over 9. So this is going to be our final answer. So I'm going to box that in red. So in review of all the example, when working with x squared, the opposite of square is square root. But pay very close attention, especially this example and its form. So that way you want to be extra careful is if you have a fraction over here. So if you have a fraction, it is possible that you could split it into two square root and check if you can do the square root of the denominator. Now, if you cannot, I repeat, if you cannot do the square root of the denominator, then you're just simply going to leave it as one big square root. Now, the reason we split it into two square root, one for the top and one for the bottom, you want to check on the denominator if you can do the square root of the bottom. So the square root of the denominator. In this case, we can, which is why we have 9 in the denominator. Now, if we cannot, which you will come across, if you cannot, then you just leave it. So you rewrite it back into one square root, just like how you have here in blue. But again, always check if you can. If you cannot, then it's going to be one big square root over the whole fraction.